Selamat sore Bapak dan Ibu. Hi everyone. Thank you for attending this workshop. So I hope you learned a lot of new things with the speakers. I'm going now to share my presentation. All right, can you see it properly? All right.
Yes.
So yeah, my talk will be quite simple and straightforward, much shorter as well. The idea is just to give you a little overview about how technical diving can be used as a mean of exploration, but also study of the mesophotic coral ecosystems in Indonesia. So we are working on this COSMARINDO project in collaboration with Luminocean to study specifically coral spawning at mesophotic depth. So I will give you a brief overview of how we do that. Because as Frederick mentioned, mesophotic coral ecosystems are quite difficult to access with regular scuba diving equipment. You don't have a lot of time, and it's also costly if you want to rent a submersible.
Tapi ini juga sangat mahal jika kamu menggunakan kapal selam atau robot yang kecil untuk
sampling. So yes, in this project with COSMARINDO, we are using technical diving, and we are using a special scuba diving equipment, which is called the closed circuit rebreather. So this is the machine that you see on the picture. It's a machine that basically recycles the air we are breathing, and with how do you call with some specific kind of filters and mixes, we can go deeper and stay longer when we are diving. So this is how it looks like on the back of a diver when it's underwater. So as you can see, it is a kind of backpack that you are carrying, and this backpack is filled with electronics. You have a breathing loop where from the diver is breathing, and then two small tanks, and that's what we are going to breathe during the dive. So inside the backpack, besides the electronics, we also have a kind of filter which is basically fixing the carbon dioxide that we are exhaling. Because using a rebreather, it's a bit like breathing inside a bag, actually. So if you are breathing in a bag at one point, you will pass out because you will have too much carbon dioxide and your body will not be able to cope with that. So that's why we have this filter that fixes the carbon dioxide that otherwise would be toxic. And of course, we have oxygen tank that is added, that adds oxygen, because your body is going to use oxygen during the dive, and you have some oxygen that is automatically added, injected in the breathing loop. However, when you do deep dive, you can't use normal air. So I remind you that air is composed of 21% of oxygen, 79% of nitrogen, and both nitrogen and oxygen become toxic when the depth is increasing, okay? You have heard of nitrogen narcosis, and there is also hyperoxia when you have a partial pressure of oxygen that is too high. And that's why we are making our own breathing gas, and we are adding a third gas in the equation, and this gas is helium. Helium allows us to reduce the percentage of nitrogen and oxygen in the breathing gas so that we can go deeper, because helium is an inert gas. It doesn't have the bad effects of oxygen and nitrogen when the depth is increasing. It just gives us a very weird voice that you would find funny if you were hearing that, but I'm not gonna play that sound now. However, you need to calculate the right amount of helium for each depth. So you can't use the same breathing gas if you are 50 meters or 100 meters. So it's a bit like cooking, you know. You have a recipe depending on how deep you're going, and you are baking your own gas mixes depending on how deep you go. However, also doing deep dive is not as simple as it sounds. I mean, it's like you are diving in a cave. It's like you always have a ceiling above your head. You can't go up to the surface immediately if you have a problem, because you have extremely long decompression stops that are mandatory. It's not something that you can skip. For example, if you spend 1 minute at 100 meters, you have 5 to 10 minutes of decompression. So can you imagine if you are now spending 30 minutes at 100 meters to conduct your scientific work, then it means you have up to 5 hours of decompression, 5 hours during which you cannot go back to the surface. Okay, you are stuck underwater. Otherwise, it's a big problem for your health and your life, actually. So that's why all the problems that you have underwater, that you might have underwater, need to be solved underwater. Okay. And that's also why you will see on the picture I will show you later, we are bringing a lot of emergency tanks. So these are regular scuba diving tanks that we also carry with us in case of emergency. In case our rebreather stops working, we can still go up to the surface following the long decompression stops. So doing a deep dive, to do a deep dive, you have a lot of calculations to do to know what kind of breathing gas you will use, how much emergency gas you are bringing, and all of this needs to be calculated beforehand, and you have to stick to that plan. So doing a deep dive is not something you can improvise and one day just go and say, okay, let's go deep diving today. You need to plan it well, and you need to dive according to the plan. It's very important. So this is how we look like underwater. We are carrying a lot of equipment. I'm going to detail here a little bit to give you an idea and why we are carrying this. So first, a kind of rocket at the front. It's called a DPV. It's a kind of underwater scooter. It's something that helps us moving around, because we are carrying so much equipment. It's difficult for us to swim. When we are deep, we have to minimize the level of efforts that we are doing. So we need something to make it easy for us to move. It's also a safety equipment, because when you have very strong current that kicks up, we can still minimize the drifting, to not drift away too far. We are using dry suits for these long dives, because even if we are in the tropics, Indonesia is very warm, but after 5 hours, you really get cold, and it's important to stay warm for decompression. We have also a lot of safety equipment, like I said. So you see the bailout tanks, so the emergency tanks that are only used in case of emergency. And we then carry, for example, lights and video camera for monitoring the reef, and sampling equipment or loggers if you want to deploy loggers during the dive. So this is how reef can look like in Indonesia. And the advantage of technical diving for this kind of study is that divers can cover quite long distance underwater if you want to do a survey, but you can also collect high resolution images and collect samples, do measurements and these kind of things. If you get closer to the reef, it's like this on some reefs, on some mesophotic reefs. As you can see, it's extremely diversified, and Indonesia is at the heart of the coral triangle, as you know, and mesophotic reefs are also extremely rich, extremely colorful, and a lot of different species that you can find there. So you have a lot of sponges and soft corals, but in some places you can also find hard corals, like Frederick clearly explained before. And the deeper you go, and the less hard corals you will find, because notably light is decreasing and water parameters are changing. And during the COSMARINDO project, we are actually planning to conduct preliminary studies on these hard corals to understand better their distribution, but also their spawning patterns that are quite not well known so far, especially in situ, inside, like in the natural conditions. I just want to do a little brief aside regarding the threats on mesophotic reefs. Frederick mentioned about anchor damage. You are well aware about global change that is also affecting mesophotic reef, of course. But you also have plastic that is heavily impacting those mesophotic reefs. On every dive we are doing, we find plastic. Those plastic bags are terrible. Like the rice bags, because they are shedding, and those plastic thread can entangle corals and choke animals. So yes, and to reduce again our plastic consumption. Back to the divers and the deep diving. So divers can do a lot of things. As I said, in this picture, you can see one of my colleagues collecting water samples for environmental DNA. You can see on the right side all the tanks he's carrying. All these tanks are only for emergency. They are not to be used. If everything goes well, they won't be used. So that's just for emergency situations. Divers can also deploy data loggers to monitor the environmental conditions of the reef, because it is important to understand what parameters can influence habitat biodiversity, but also the behavior of marine organisms, including, for example, the spawning patterns. So having loggers deployed at different depths on the reef really help understand the differences between shallow and deep, especially in the current context of global changes and global warming. Divers can also deploy coral egg traps, like Luminocean has been doing now for a few years at shallow depth. So you can do the same at mesophotic depths to try to monitor coral spawning. So hopefully in the coming years, we will learn more within this COSMARINDO project, and we will have some exciting results to share with you. And I just want to also give you show you a few pictures of fish as well that you can find at mesophotic depth, because many people think that there is no more life and all the fish maybe that you can find are ugly and scary. But actually, you have a lot of different fish species down there, and very colorful one. And that's also the advantage of technical diving, is that you can use divers to document the very rich biodiversity that you can find on the reef. So here, for example, you have small fish like that called Tosanoides anpatris. So it's a species that is only live deep on the reef. Another one here is a pygmy angelfish called Abe's angelfish. And that's, again, a species that only lives deep, and you will never see it shallow. This is one of my favorite, the red stripe big eye. So that's a species of fish that is believed to live between 100 and 200 meters. And you can see from the picture the adaptation to low light environment with this very big eye that helps the fish hunt prey or hide from predators in a low light environment. And one last one for fun, this is a deep water triggerfish called Rhinacanthus abyssus. This fish has never been photographed before in its natural habitat, because it's, again, a species that is only encountered deep. And you will never find it shallow. So you see mesophotic reefs, they have a lot of corals and sponges and things like that are very important, that builds the structure of the habitat, but they also host endemic species of marine
Yang sangat
organisms.
penting. Kemudian juga ada spesies endemik.
You only find deep. And that's why it's important also to think about conservation of those deep reefs, because they have unique species that cannot live shallower. But you can also find some fish species that can live shallower, and actually juvenile fish of reef fish can be found at mesophotic depth. And this also highlights that in some cases, like Frederick said, you can have a tight connectivity between shallow reef and mesophotic reef. And these mesophotic reef, because of the low light that you have there, it's a good way for small fish or juvenile fish to hide from predators. So it's believed that in some places, these deep reef habitats are used as a nursery ground because small fish, juvenile fish, are more sheltered from predation. So they can grow safer in the dark environment before moving shallower. So it's another reason why understanding more about mesophotic reef and preserving them, and as the same way as we try to preserve and protect shallow reef, we should also insist on conservation of mesophotic reef. And it's important to raise awareness about their conservation. So I thank you all for your attention, and if you have questions, feel free to answer if we can.